Hello, everybody. Thank you for attending our last session here in the Berlin room. Once again, my name is Matt. I'm with the QT company. I work in our Santa Clara office. And I am pleased to present Ulf Hermann, who is also with the QT company. And with that, we'll let you take it away.
Yes, hello. Oh, it's so nice that you're all here. I'm going to talk about Qt SCXML today. I'm Ulf Hermann. I've been working at the Qt company for about 3 years, mostly in tooling. But lately I've also contributed to our new SCXML module and also the tooling support around that. And I'm going to explain to you what it's all about, what SCXML is, and the awesome things you can do with it. So this is what I'm going to do. First, I'm going to explain a bit what SCXML is and yeah, the general concepts around it. Then I'm going to explain what Qt does with it. So what is the whole Qt SCXML module about? Then I'm going to give you a quick walk through the C++ API, and I'm going to show an example for that, which is an FTP client written in SCXML and C++. And then I'm going to show you the QML API with a traffic light written in SCXML and QML. And in the end, I might talk a bit about data models. Anytime you have any questions, I'm very happy to answer them. Don't be shy to ask. So, what is SCXML? SCXML is state chart XML. That is a language specified by the W3C to write finite state machines and to represent them in XML. As has been around for a while, and there are many tools to manipulate it, to create, interpret, process it. So it's kind of a standard, and yeah, that's a good thing to work with. So some basics. On the right, you see a typical state machine. Actually, the one I'm going to show later, the traffic light, can be in a red, yellow, or green state. And the yellow state has the special property that when it's coming from red, it should also light up the red light. And that's what you need nested states for. That's the nice thing about SCXML. It allows nested states. So the yellow state has two ways of being represented. Either it's coming from green or it's coming from red. In order to transition from one state to another, you need events. So in SCXML, all transitions are triggered by events, and they can have conditions, and they can trigger further events, and they can write the data model and so on. But the event is the most important thing. And as I just mentioned, data model allows you to keep global data in the state machine and to do arithmetics on the contents of events and so on. And then there are many more things that I'm not going into detail right now, like invocable services, history states, parallel states, initial states, final states, and so on. But that would be too much for the time we have. And what we have here is enough to show you the examples. But all this is specified. You can read it up. The standard is actually fairly readable. So there we go. So what does Qt do with that? Why? How does that work? QtSCXML is actually an implementation of the standard, of the SCXML standard. The SCXML standard mandates how those states and transitions and events are going to be interpreted and how the state machine, once formulated in this SCXML way, moves from one state to another and what it does with certain events. So QtSCXML implements that and allows you to compile SCXML documents directly into C++, which can be directly embedded into your application. Or you can load the same SCXML also at runtime, which is a bit slower but gives you versatility to load your state machines from anywhere on the internet. States and events are mapped into Qt constructs. So basically, every state is a Boolean property of a state machine. So you can actually ask the state machine at any time, OK, are you in this state? Are you in that state? And notify me, please, when you enter the state, or notify me when you exit the state. And the same with events. You can get notified about events that are sent out of the state machine, and you can send events into the state machine. And in the end, we also have a graphical SCXML editor, which will be released with Qt Creator 4.2. So Qt SCXML, there was a tech preview in Qt 5.7. We changed basically everything. So the final version will be with Qt 5.8. And if you're interested in it, don't look at the version in Qt 5.7. But from Qt 5.8 on, it will be binary compatible and source compatible. And it will follow all the promises we give for released modules. So you can be fairly certain that this will work for the foreseeable future. So let's talk about some important classes you will want to use when working with Qt SCXML. The first one is Qt SCXML state machine. That's a main entry point to the API. It's a base class of all compiled or interpreted state machines. And you can query it for state changes and submit and receive events. And related to events, the class of those events is QSCXML event. And they have a name, and they can have data, which is QVariant, and which is customarily often a QVariant map, actually. And the state machine will like send those things out, or you can pass them in when submitting an event. So let's talk a bit of about the C++ API. Yes? Transitions are not first-class citizens in the Qt API, because transitions are always triggered by events. And a transition consists always of one state you're leaving and another state you're entering. So you can like find out all about the transition with the API we have. And this is how you actually do that. You can connect to a state here, and you get a parameter when this is mirroring the QObjectConnect method, actually. So this is like QObjectConnect, except that the signal you're connecting to is not a signal as in some function pointer from a QObject, or a string embedded in a signal macro or something like that, but just the name of the state you see here. And you can connect any slot with context, without context, or a lambda, or anything you can connect to a QObject signal with this method. So machine would be some SCXML state machine. You do connectToState, and you get a Boolean parameter that tells you if you're entering the state or if you're leaving the state. And this is basically a transition that you're seeing here when you get that signal. And something has happened, right? And so you can check, OK, if we're in the state, we do something. And if we're not in the state, we do something else. And there are some static functions in Qt SCXML state machine that allow you to write those handlers without querying this parameter all the time. So if you only want to connect to the event when we're entering a state, you could also write QSCXML state machine on entry here. But you'll see that in a minute in the example. Same way you can connect to an event. The string you see here is an event specifier. That's actually something from the SCXML specification. Events can be nested, same as states. So you can have like one very generic event that's sum in this case, and then it might be sum.event and sum.event.blah or something. And whenever you receive sum.event.blah or sum.event.blob or whatever, this event handler would be called. And then you can use the data or the name or anything connected to this event. And the same way you can submit an event, specify a name, and some variant that you send as data. So that would be a variant map here with something you might tell the state machine. So with this in mind, we can actually build an FTP client, and it's very simple with SCXML because RFC 959, which is the thing that specifies FTP, is specified in terms of state charts. Those state charts look a bit weird because they didn't have nested states back then. They get very simple when you write them in SCXML, which I'll show you in a minute. And I will do some plumbing, and I'll show you how that works mainly. And then we'll download a file from an FTP server. So this is what the RFC looks like. You don't have to understand this. I'll just show you the end result because time is limited. So let's open Qt Creator here. And let's make this a bit bigger. Now let's see. Other example, what I actually want to show you is this. So what we see here is one begin state, which is the state from where the state machine expects us to ask for something, like expects the user to say, okay, get me this file or log me into this FTP server or whatever. And those are the events that you see here and here. And there are two kinds of those. Some initiate the data transfer, those are these here, and some don't. And then whenever we receive a well-formed event from the user or from somewhere else, we leave the begin state and go into the waiting state. And this transition is connected with a entry handler on the waiting state, where we verify the event and send another event out that basically tells the control channel to actually send this now. And then we wait for the server, and the server might send us various replies. For example, any reply with a 200 number means success, and we go to the success state, and from there we can send the next command. And any event, any reply with a 400 or 500 code means, okay, server tells us it cannot do that, and that's a failure state. And then there's a special state here, 100, which means, okay, you can start transferring data now. And that's basically where we then wait for the server to call us back on the data channel and send us the data. Now I was talking about data and control channels. That's just how FTP works. And there's not much to those. So a control channel basically is a TCP socket from which we expect some weird line ending convention. And that's basically all it does. And yeah, it also like buffers the data and waits until the whole reply is there and replaces the line endings and then tells us what the reply was with this signal. That's all the control channel does. Data channel is even simpler. And it has an FTP server. It waits for the TCP server to for the FTP server to call us back. And if it gets in connection, it just dumps anything that comes over that connection to the over the signal here. Where was it? Here, data received. So let's connect that. First, we compile the FTP client SCXML we just saw into C++ by adding it to the state charts variable in our QMake project file. And of course, loading the SCXML module while we're at it. And that gives us a header and an implementation file. So this one is the header. And you see all those properties here, which are the states that I just explained. And an implementation file, which is just a bunch of numbers that tell the main QSCXML state machine what states there are and how to transition and what events there are and so on, and, strings and yeah. Basically, it's a custom-built meta object. But back to our implementation, to our plumbing. So we instantiate one of those FTP clients. That's the actual state machine. And we get the data channel and the control channel. And anything coming over the data channel, we just dump on the console, like this. Simple. So if the control channel tells us, OK, we've seen a reply, then we translate that into an event for the state machine. We say, OK, reply something with the first digit of the reply code. So reply codes can be like 102 or 205 or something like that, or 404. Everybody knows that one. It's the same actually in FTP. And any parameters the server might have sent. And then whenever the state machine says, OK, I actually want to send a command to the FTP server now, we listen to this event, which is what I just showed you on the on-entry handler on waiting. And then we translate that into an event sent over the control channel, which is basically we cut off this submit.command so that only the event name is left, and we take all the data as a byte array, and off we go. So what's the minimum way to get a file from an FTP server? We need to log in. We need to set the port where the server can call us back. And we need to post a retrieve command. And the only way to send those commands is wait for the state machine to be in the begin state, which is where it expects us to send commands, and then send the next command, right? So we get to the begin state. And when we enter that, this is the on-entry function, so that we don't have to check for the Boolean parameter. So I just wrap the lambda I have here. This is a lambda into on-entry, and then it's only called if the Boolean parameter is true. So if we don't have any commands left, we're done. Otherwise, we take the next command and submit that to the state machine. And then there's a special thing. When the state machine asks for a password, we send it an empty one, because we are just assuming a anonymous login. And that's it. We connect to the server that was given by a parameter And we open the control channel, and when everything is fine, we can start the state machine. So let's try that. I'm just downloading a file from the Debian FTP server now. Yeah, and I don't have a network connection. Great. No. I'm actually not downloading the right thing. This is what I wanted to download. There we go. So you can see here, I put some QDebug messages in, sends the user command, it sets the port to a weird number. We don't have to go into details of that. And it retrieves the file. Any questions so far? Maybe I've confused you all. But you can see very well from this example, like how I'm connecting to the various events and states. And it's also in the SCXML examples. So you can go back to that and like copy from it. Yeah. So the question was if in those lambda functions I know anything about the history, like where I came from and where I went to. No, I don't. And that is sort of the point. You can write the second handler for leaving a state, and then you know where you're coming from. You can use SCXML history states, then you know where you're coming from in SCXML. But basically, the whole point of a state machine is that the state is limited to what the state machine actually, which state machine the state machine is in now. You shouldn't have any hidden other state somewhere. Yes?
It only has one state. So the purpose of the state machine is an object could change its behavior based on its state without changing its interface.
So
that's the design pattern of the state pattern.
Yeah, you should not, like the whole idea of using a state machine is that you should not care about where it came from. It should just be clear that this is a legal state and that's the only thing you can react to now.
You could have multiple transitions on the same exact entry. It depends where you came from, which one gets initiated in the background.
No, actually SCXML specifies exactly in which order the entering and leaving states are entered and left. And this is only a function of the structure of your state machine. You don't really need to know. You don't need
yellow
to keep
light.
yellow
light needs to know if it's coming from red or green, right? Yellow light needs to know if it's coming from red or green.
No,
right?
Actually not. That's why we have two substates. I can show you that. So we have the red going green state, and we have the green going red state. So if you are going from green to red, you're going to connect to this state and not to the yellow state. Or if you want to switch on the red light too, you're going to connect to this state for the red light. I'm going to show that in a minute, and not to the general yellow state. And this is how you do it in SCXML. Okay, but back to the general tale here. So you've seen the demo. the first one. And now I'm going to talk a bit about the QML API, and you're going to see the traffic light as the second example. So how can you expose your state machines to QML? Well, that's easy. An SCXML state machine is just a Q object. So you can do either pass that in as a context property, or you can QML register type the state machine and instantiate it from QML. And all the properties on the state machine will just be properties on the state machine in QML, and you can bind to them. All the states are notified via the signals that we've just seen. You can bind to the states as Boolean properties and, for example, set visible attribute based on the state. In order to receive events, that's a bit more complicated because of the event specifier syntax from SCXML. So we have an EventConnection that I'll show you in a minute, where you can actually specify those event specifiers and then get a signal when that happens. And of course, submitEvent is Q invocable, so you can just call it from QML. So that would be binding to a state here. You have a rectangle, and it's green, and it should be visible when the state machine is in the green state. And that's it. An event connection looks like this. Say you have some state machine, and eventually it sends an event called update display, and then you want to do something with your QML. So what you do is you set up an event connection. You write the event specifier for update display, which is pretty simple in that case, but it could be any of those dot and asterisk things that you know from SCXML. And whenever an event occurs that matches this event specifier, you will get the signal, and then you can use its data and its name and whatever else you have. So how does it look like? We've just seen the traffic light example here. So to reiterate, can be red or green, and can be yellow. And if it's yellow, it can be coming from red or coming from green. And as a bonus, we can also smash it and repair it. And when it's smashed, it's blinking. It's switching between yellow and blank. So how do we do that in QML? How do we connect this up in QML? Basically, the first thing we do again is we compile it. And it ends up at this file here, at this header file, which has all the states as Boolean properties again. And we register that type to the QML engine with QML register type with this. And then we import it like this and instantiate it here. And we just say, go, run right away, start right away. And then we can connect items to it. So a light is a rectangle with the corners cut off, like this, and some margin and so on, and the color as the most important property. So those lights are instantiated here and bound to the state machine's properties. Yeah. So the red light is visible when the state machine is either in the red state or in the red going green state. And the yellow light is visible when the state machine is in the yellow state. So in any direction, or in the blinking state. And the green light is only on if the state machine is in the green state. And that works. You can try that here. Go. Yes. So a very simple traffic light you see here. Switches from red to green. One thing we haven't used yet is the ability to crash it, right? So let's do that. I left that suspicious little rectangle here. You can probably guess what it's for. So let's put a mouse area in there. That fills it. And whenever we click that, we submit an event. And which one do we submit? If the state machine is working, then we smash it, and otherwise we repair it. And I mistyped here. And that should do. So this works again, just the normal way. And now it's broken. And now it works again. So this is all I have to do in order to integrate the state machine into my QML. So what about data models? Well, data models are a somewhat difficult topic. Well, SCXML has data models. They are mainly not about data, but for scripting. So you can write scripts in whatever language the data model supports and execute them on entering or leaving a state or on transitions and so on. They also allow you to store arbitrary data in the global context. And they are not very portable. The only thing that the SCXML standard actually mandates is a null data model, which has exactly one operation, and that is in. So you can query the state machine if it's in a certain state. Also, those scripts are fairly hard to debug because that's script code embedded in XML, and well, whoever has done web development before knows that this is kind of a pain. Sometimes you need them. Sometimes you need them for initial configuration, or even for the simple arithmetic expression I did before, where I concatenated the submit string to the previous event's name. You cannot do that without some kind of data model. Qt supports the ECMAScript data model, which is basically JavaScript. You can use any JavaScript in your event handlers and entry and exit handlers and so on. That's what I used for the plus operation, because plus and two strings in JavaScript conveniently just concatenates the strings. It also supports the null data model, of course, and you can write your own custom C++ data models and execute C++ code on entry and on exit. I wouldn't advise you to do that, because you should just connect to the events and states and do that outside the state machine if you just want to execute arbitrary code there. Should try to keep the state machine clean and without hidden states somewhere in global data and so on, because that goes against the philosophy of finite state machines, actually. So Any further questions? Yes?
The states, pretty loud. The states, when they're loaded in and become properties, is there any differentiation between a state versus a substate, or do they all just show up equally as the same properties? So specifically you had yellow and you also had red going green and green going red. To the C++ code in the QML, it just sees them as properties with difference.
The states are simple Boolean properties, and that's kind of on purpose because the information what kind of state you have there is contextually apparent because you've written the state machine, right? So, and you're connecting to a specific state.
Right, but all your top-level states, you could only ever be in one of those.
Yes.
So you could perhaps have a property that identifies what
you could have
primary
a parallel
state you're in. So that's
no,
why I asked.
Actually that's not true. You can have parallel states in the SCXML.
Okay. I've got more to learn.
Thanks. State machine is not a new idea in Qt. When we develop our applications, we utilize the Q state machine or state machine in QML a lot. So why can't you add the new functions such as load SCXML files into the state machine, the functionality to the existing module? So what's your point to develop a complete new module?
In 5.7, we actually used Q state machine. So you loaded an SCXML file, and it was what it generated was a Q state machine. But that has certain drawbacks. The first and most important one is in a Q state machine, every single state is a Q object. And if you have a big state machine, of which there are, with a couple thousand states, that does not scale. So you don't want the Q object just represent a Boolean. And we cannot change that because Q state machine is public API, and we are bound by the compatibility promises on that. So we had to do a new thing. Also, Q state machine allows you to do things that are not possible in SCXML and vice versa. So there are some corner cases where Q state machine is actually not compatible with SCXML, and we wanted a standards compliant SCXML implementation. So that you can load a pre-existing SCXML document that you've developed over years of fiddling, and it should just behave the way it's supposed to. Actually, we not, but we have customers who do. Yeah, I know that Q state machine is different from SCXML state machine. Quite purposely so, because it's incompatible with SCXML in certain ways.
Okay, so it is much performant than the existing module, right?
It should be way faster than Q state machine for big state machines. Yeah.
I have another question. I'm sorry. When we apply the scheme of a state machine, we sometimes got confused, since sometimes we feel that we just put our application, our idea, to fit the structure of state machine, to utilize, to maybe make our application more fashionable. So, what's your point about utilizing state machine?
Yeah.
I mean, sometimes it is fit to use this scheme, or sometimes it is not, to just put your application into it. Thanks.
Well, I can give my personal experience on that, and that is you should use state machines if you have a well-defined problem that actually results in a finite number of states. So for network protocols, it's nice. Like FTP just has a finite number of states, and you should never get it to a state that's outside of this schema. But if you do UI prototyping, you probably end up with a state machine with an explosive number of states, because you constantly change that, and constantly the customer wants something new, and you have to add something here and move something there. And state machines are, and all the code that you connect to them, are notoriously hard to refactor. So instead of properly refactoring it, you end up like adding states around it. And that just does not really scale. But that's just, I haven't done too much stuff with state machines itself. So take that with a grain of salt.
Are there any other questions?
Just a question. In the examples, there were a lot of use of lambdas. Can you use it without it, or it has dependencies?
You don't have to use lambdas. No, you can use simple Q object slots, just like that. I just used lambdas because it was convenient. Yeah, I can probably like, yeah, okay. But require, if I want to use something else, it requires that I write another class there. So maybe not now.
Are there any other questions? All right. Well, thank you very much for attending this session. And we're going to be having our final wrap-up of the event in the Helsinki, the main room there, in several minutes. So maybe go stretch your legs, and we'll see you in a few minutes. Thank you.